All right, section 0.4, we're actually going to solve some algebra problems. So the first step it says here is to clear fractions. We almost never need to do that one, but it's there in case it comes up. Combining like terms, yes, sometimes you need to do that for certain percent problems. Combining like terms on opposite sides with addition or subtraction. So there's combining like terms on each side where you're just going back to your lesson on combining like terms. You look at one side of the equal sign, combine like terms, look at the other side, combine like terms. So each side is as simple as it can be. So maybe you write simplify each side. And then we usually have a variable on one side and a number on the other. But sometimes you have a variable on one side, a number, and another variable on the other side. So you want to put all your variables together. So that's what step 3 is talking about. And then division is usually your last step. So don't try to divide until the end. There might be some exceptions to that, but I would just keep it in mind. No division until the end. And then, of course, you can check your answer by plugging it back in. So the addition subtraction property says that you can add or subtract whatever you want to both sides of the equation as long as you do it to both sides of the equation. So that's what I have right here. Oh, let me try that again. All right, let's try one. So x plus 4 equals 12. We want x by itself, so I need to get rid of that plus 4 by undoing it with subtraction. So you always do, if there's something added or subtracted to your variable, you want to do the opposite of what's being done. So in this case, 4 is being added. So if I subtract 4 on both sides, now that 4 minus 4 is just 0, so x is by itself, and 12 minus 4 is 8. So my answer is x equals 8. For number 2, 7 is subtracted from y, so I want to add 7 to both sides. And I'll get y equals 18. Number 3, so 3 is added to z, so I need to subtract 3 on both sides. So z is equal to 7. Okay. So let me know if any of that doesn't make sense. The other rule we have is the multiplication division rule. It's kind of like the addition one, but in this case, if you want to undo multiplication, you'll use division on both sides. And if you want to undo division, you use multiplication on both sides. So this is, examples 1 and 2 are usually when you're towards the end of solving an equation. And your last step is division. So you could rewrite number 1 as 4 times x equals 20 if it helps. Just to note that if there's no operation between the number and the letter, it means that it's multiplication. So if it's multiplication, I would undo it with division. The 4 divided by 4 just becomes 1x, and 20 divided by 4 is 5. And you can leave it like that or just write it as x equals 5. Similarly, our number 2, it's 0.3 times y equals 15. So to undo multiplication, I divide both sides by 0.3. So the 0.3 divides out to become 1y equals, I have to do that in the calculator, 50. So I like to drop that 1 and just write it as y equals 50. And here's one where you would actually you could multiply or divide this one. It turns out that if you divide both sides by 1/3, it's the same as multiplying by 3, because that's how division of fractions work. So just to be consistent, I'm going to do division like we've been doing, and you should get z equals 33. Now, if you were taught to do that one by multiplying both sides by 3, that's fine. You're going to get the same answer. I can show you it over here. I'll use another color. 1/3 z equals 11. And if we multiply both sides by 3, 3 times 1/3 is just 1. So 1z equals 33. So z equals 33. And I kind of made it look like that's an exponent there, but this is multiplication. All right, so here we have some mixed practice. Solve each equation and check. All right, so there's something added to x here on example A, so I need to subtract it, and then I get x equals 7. B, here's one where you could multiply or divide. You could rewrite it as -1/2 p equals 1/12. Remember, we saw that in an earlier video where if a variable is divided by a number, you can pull out the fraction and put it in front. And now I can see that I could divide both sides by -1/2. The -1/2 divided by -1/2 is just 1p. And then on the other side, I'm going to get -24. Again, you could multiply both sides by -2. Whatever makes more sense to you. All right, C. All right, here's an example of one where I have like terms on both sides. So I want to subtract the 14 on both sides so that I'm left with 0.40y equals 40. And now my last step is to divide the 0.40 on both sides. And I get y equals 100. So that's a two-step problem. We had to subtract and divide. D has distributing, so we get to use those distributing skills. 3x plus 6 equals 9x. I like for all my variables to be on the left and all my numbers to be on the right. So I'm going to subtract 9x on both sides. So I get -6x plus 6 equals, now 9x minus 9x is 0, and it's important to keep that 0 there. Sometimes students don't know what to do after they've subtracted and there's nothing left. So we just want to make sure you write 0. And then I'm going to subtract 6 on both sides. So -6x equals -6. Divide both sides by -6 to get rid of that -6 in front of the x. So finally we get that x is equal to +1 because a negative divided by negative is positive. You don't really have to worry about those rules as long as you're using your calculator, because your calculator knows all the negative rules. Example E. So here we might want to write it as 1x plus 0.25x equals 100. You don't have to have that 0 in front of the decimal, but I like it there. This is 1.25x if you combine like terms, and then divide. So those are gone, and I get 100 divided by 1.25, which is 80. All right, and then our last example, again, I like to write it as 1 minus 0.02x equals 5. You'll notice I stuck the 0 in front of the decimal again. And that is if you combine those like terms, 1 minus 0.02 is 0.98x. And then divide both sides by the 0.98. So the 0.98 divided by 0.98 is just 1. So I get x equals 5.102. And then this is something that you'll never have to do in this course, but I just wanted to give you one example where you can see all of the steps. So it's a little bit, it's more than you need, but it's a way to show all the steps that I showed you at the beginning. So the clear all the fractions one, here's one where you would have fractions to clear. So you can see that we're multiplying both sides by 2 to get rid of the fractions. And once you do that, it's usually just a bunch of distributing, combining like terms. So when you get down to this one, it's more reasonable with what we would do. So from here, it says you can either add 6 to both sides or subtract 80 on both sides. It doesn't matter. And I chose to add 6 to both sides. And then I subtracted 14x to get all my x's on the left. And then finally, when you get here, you get to divide, and this is your answer. If you get a fractional answer, just notice if your homework question is telling you to leave it as a fraction or if it's okay to make it a decimal. If you are putting in it as a fraction, make sure it's simplified all the way. Most calculators will do that for you.